Hello everyone, welcome to another exciting episode of Surpac Tutorials. My name is Kobe and I'll be running you through the tutorials as usual. If you have watched the previous lessons, you would realize that there has been a change in the Surpac interface with regards to the tool icons here and the icons for the files in the navigator pane. This is because I'm using a different version compared to the previous one. Now I am using Surpac 6.5.1 version, but in the previous lessons the version used was Surpac 6.1.4, so you can see the advancement. By the way, the functions are the same, no need to be scared or don't get worried. I will explain each and every function that we use in the subsequent tutorials to your understanding. Alright, in the previous lesson we sectioned and digitized mineralization zones or regions based on our geological intuition or interpretation, and these segments or string is what we came up with. So from the mineralization trends we digitized and we had these segments or string, and this is what we are going to model our ore from. As previously discussed, you need to be saving your project as you progress because you would never know what may interrupt your project. So saving your work is a very great part in your project. So you need to be saving your work as you move along. In saving, you can click the tool icon for save here, click on it. Let's say I want to rename this file all outline.string. I want to give it a different name, all underscore model. I'm using underscore because Surpac does not accept spaces between file names. So I'll click apply, and straight away the file will be created in the work directory of the navigation pane. So I can exit graphics and bring the file here, and it will be the same as the previous one. Another way of saving a file is using the file menu. Click on it and click save as, and you'll be presented with the save file window. Again, you can come to the function chooser box and type xf, which is the function shortcut for save file. Press enter on the keyboard and there you have it. The form for save file will appear. Okay, now the next thing that we are going to do is to look at some of the things that we can do before we model our ore. You know, these segments were digitized with reference to the mineralization zones. So we are going to look at some of the things that we can do before we create our ore model. Before creating a solid model, we will use this wireframe to calculate digitized segment grades. When I say wireframe refers to the string or segment representing the ore zone. So in this case, these segments or string is called a wireframe. Alright, so our first task is going to be determine the average grade of a digitized segment. As I initially said, these segments were digitized taking into consideration mineralized zones. So we are going to determine the average grade of a particular segment. The first thing that we are going to do in order to do that is to display our drill holes. So I'll go to my database which has been loaded. I'll click on it and select display drill holes. Then I'll view from the assay table with the fill gold values. Then I will uncheck the constraint box because I don't want to apply any constraint. Then I'll click apply, and good, my drill holes will be displayed. Now the next thing for me to do is to section. I'll zoom to data extent, then I'll go to section, then I'll select define. There are so many ways of defining a section as initially discussed in the previous lessons. I'll use the graphical method. There are a whole lot of sectioning methods here, but I'll go for the graphical selection method, which will allow me to click and drag a section plane. Now distance forward of plane, at what distance from one section plane would I want to capture information? That is, I want to capture information 5 meters from the forward plane, from the plane forward of it, and 5 meters backward of the plane. So I'll enter 5 here and I'll enter 5 for the backward. Now section by, we have interval and range. For the range, we are supposed to enter a value for the start, the end, and an increment, but we do not want to do that. We want to section by an interval, so we go by this one, section by interval. Step distance, at what distance from one section plane would you want to move to another section plane? That is, if I should start my section plane from 0, the next, in this case we have already 50, the next section plane is going to be 50, 100, 150, and so on and so forth. So Let's say I want to move from one section to another at distances of 40 meters. So I'll enter 40 and I'll click apply. Then in the status area, it says click and drag to define the cutting plane. So whichever segment that you would want to determine the grade for, you click and drag the line along the drill hole trace or the digitized segment. So I would want to determine the grade for this segment. So I will click here, click and drag along this section of the drill hole or along the digitized segment, and I'll leave it. And there you have the digitized segment here. Okay, so now we are going to determine the average grade for this segment, and this is what we are going to use this function here. As you can see from the tooltip, digitized segment grade. I'll click it and I'll be presented with the digitized segment grade window. Another way of displaying this is to go to sections, digitized segment grade. I'll click on it and I'll be presented with the same window. All right, now on this form we have database. It is the database that we want to do the calculation from. Remember, everything is with respect to the database. And we have the composite method. Just a brief explanation of composite. In drilling, a composite refers to bulk samples that is collected into sample bags for a particular drill interval along the drill hole. These samples are then taken to the laboratory for metallurgical assays or mineral analysis. So let me click the drop down so we see the types of composite methods that we have. We have the length weighted and the area weighted. I'm going to explain this one after the other. With the length weighted composite method, digitized segment grade is calculated on the basis of the mineralized zones that fell within the digitized segment. That is the portion of the drill hole that captured mineralization. So this is what I'm talking about. If I should zoom into this segment, with respect to this drill hole, the length weighted calculates the grade of the digitized segment, incorporating only this portion of the drill hole that captured mineralization. Again, with respect to this drill hole, the calculation makes use of this mineralized portion or zone that had gold values or mineralization to calculate it. Okay, so I'll go back to the form. Then with the area weighted method, the area weighted method calculates the grade of the digitized segment, making use of the entire length and width of the digitized segment. Remember, area is the product of the length and the width of an object. So the area weighted calculates the grade of the segment, making use of the entire length and the width of it. So that is the difference between the length weighted composite method and the area weighted composite method. Here we have minimum percent of samples to be included. As samples are collected from a drill hole, there is a probability of missing a fraction of the entire sample for a particular drill interval. This may be due to samples falling onto the ground or not reaching the sample collector bag, or maybe staying in the cyclone. As you can see, it has been preset as 75. The reason is that if you as in our database, our sampling interval is 1.5 meters apart. That is, at every 1.5 meter of a drill, we take samples. If you are able to capture or collect all samples within that 1.5 meter interval, you say you have 100% recovery. But in as part of any drilling activity, there may be errors and mistakes during sampling procedures and even as part of the drilling activity. So you have to cater for all these errors. So this 75 means that we are not going to include all the samples that were gathered within the 1.5 meter interval. We are saying we want to use 75% is 3/4. So we want to use 3/4 of the 1.5 meter interval. So in this case, if you are to calculate the 75% of the 1.5 meter interval, we are going to have let me use my calculator. 75% of 1.5, which is 0.75 multiplied by 1.5, and this is equal to 1.125, meaning that 1.125 meters out of the 1.5 meter interval is what will be used in the calculation of the digitized segment grade, meaning 1.5 minus 1.125, which is equal to 0.375. It is catering for the loss of samples and drilling errors or sampling errors. That is why we have here saying the minimum percent of samples to be included, which will be used in the calculation of the digitized segment grade as 75. If you are really sure about your sampling protocols or procedures and the drilling activity, you can enter any percent of samples that you would want to use in your calculation. Okay, table, field, dilute, default. I will explain this one after the other. I'll begin with the table. The table is which table in the database that we want to do the calculation from. Of course, this is a grade calculation, so we will use the assay table because the assay table hosts our gold values or grades. So here we will select assay. Then the field, from which field within the table would you want to do the calculation from? And obviously this is a grade calculation, so we are going to select the gold values. Then we have dilute. Dilution is something that cannot be eliminated but can be minimized as part of all modeling and even in mining. As observed initially, not all the digitized segments had entirely gold values. This is what I'm talking about. If I should zoom into this digitized segment with respect to this drill hole, as you can see, these colors represent mineralized zones or the ore portion. We have here no color, this representing an unmineralized zone or a barren material, or waste material. So we have to, as part of modeling or our geological interpretation, we can't do away with this barren portion within the ore, so we would have to include it as part of our modeling. That is why we need to check the dilute box to cater for these barren material that are used in our grade calculation. Again, with respect to this drill hole, for this particular digitized segment, we have another barren material. So it is recommended that you check the dilute box to cater for the barren material inside your mineralized zone. So that is it with the dilute section. Then we come to fields. D means description field. So D1 means description field 1. D2 means description field 2. Alright, so which description field do we want to save our results? We want to save it in the first description field. You can choose anyone to suit your preference. Alright, so we are going to calculate the grade of the digitized segment by using the length weighted composite method first. Then afterwards, we will determine the grade of the digitized segment using the area weighted method. So here we go. Table, assay, field, gold values, dilute, first description field, apply. Then it says in the status area, select the segment of interest. So I will click anywhere on the segment. And voila, my results will be displayed in the message window. We have digitized segment grade as the operation. String number is obviously string 1. We have the segment number 10. We had several segments in graphics, but we chose to determine the grade for this one, and this is segment 10 out of the several segments we had. And this value is the area of the segment, and this is of interest to us, the average grade, using the length weighted composite method. So I'll press escape to exit the function. Then we will determine the grade using the area weighted method, and we will compare the difference. Escape. Then I'll go back to the function. Then this time around, I'll choose area weighted with all other parameters remaining constant. Then again, it says select the segment of interest. I'll click anywhere. And my results will be displayed. Let me reduce the size of my graphic so we can view the difference in results. This is for the length weighted average grade, and this is the area weighted. As you can see, the value for the area weighted composite method is smaller than the value for the length weighted composite method, because the area weighted method calculated the grade using or taking into consideration the entire length of the segment and the width of it. So the area weighted value will be smaller compared with the length. As part of geology or geological engineering or drilling procedures, it is required that you calculate the digitized segment grade using the length weighted, because it is from the mineralized zones which were captured by the drill that are used in the calculation of grades. So note the difference. I'll clear the window and bring back my graphics. Okay, now let's view the value in the description field because we chose D1. With the same function, I'll calculate the grade using the length weighted, which is the recommended one. Apply. Then I'll select anywhere. The grade is here. Now, if I want to view the results in the description field, I can go to this icon here, which is inquire according to the tooltip. I'll click on it and select point properties. Then point properties, and it says select the point of interest. I'll click anywhere, and as you can see, we have segment number 10. The same is displayed here, segment number 10 of string 1. And these are the coordinates of the point that I clicked on the segment, and the description field is 0.521, and this is the same as the value for the average grade. Okay, because we chose D1 to save the results. Okay, so that is it for the description field area. Good. Now, as part, now let me close let me hide my drill holes, and let me close my sections and section mode. Okay, hide all drill holes. Okay, as part of geological modeling, it is required that the strings or the segment that will be used in the modeling be clockwise so that it can represent an area of inclusion. A string or segment can take two directions, either clockwise or anti-clockwise, but in geological modeling, your strings should be clockwise. The clockwise nature of the segment or string will aid in validating the solid, taking away the hassle of re-editing and other validation problems. In other words, it helps to create very simple and well-formed three-dimensional models. To check if a segment is clockwise or anti-clockwise, you can go to Inquire again, click on it, and select Segment Properties. Click on it, and it says select the point of interest. So any segment that you would want to determine its status or its direction, you can choose it. So I will want to determine for this one. I'll click on it, and it says layer all model.string, which is the one in graphics, and it is the one in the layers pane. Then segment 11.7 status is clockwise. Okay, so I can again check for this one, and that one too, the status is also clockwise. And remember, while we were digitizing in the previous lesson, we digitized in the clockwise direction. So in my point of view, I guess we have all the segments and the entire string as being clockwise. If you doubt this, you can change the entire direction of the string to be clockwise. If you are not sure whether all your strings are taking the clockwise direction, you can use a certain function to do this or to cater for this by going to File Tools and selecting Change String Directions. Click on it, and here you are presented with the window. Define the strings to be 10. The location will take you to your work directory. I'll click on it, and we are presented with the string files we have in our database work directory. So it's the all model string that I want to reverse. I'll click on it, and the file will be displayed here. I'll click Open. Okay, if I had a number attached to my file name, if I named my string in graphics as all model 1, the one will be picked up by Surpac as the ID range. And we do not have other strings apart from string 1 in graphics. Otherwise, here string range, we would enter, if we had several strings, let's say string 1, 2, 3, we are to provide which strings that we want to change the directions. So if I wanted to change string 1 and 2, I can enter 1, 2, meaning it should reverse or change the direction for string 1s and string 2s. Okay, but we are fortunate to have only one string, so no need entering a value for that field. Now I would want to start at segment 1 so that it will cater for all the segments. Then I will retain descriptions. Then for the select direction option, we don't want to make string anti-clockwise, we don't want to reverse existing direction, we want to make our strings clockwise. So you select this and you click Apply. Beautiful. Now the results are in the file or model.string. This is a function-centric method, so the effect will take place and the file will be saved in your work directory. So I can exit graphics, bring back my all model, and now I can use the inquire icon to check and see or verify if my segments are clockwise. Segment properties, select the point of interest. I'll click anyone and it says status equals clockwise, status equals clockwise, status equals clockwise. Perfect. Okay, now we are done with that. The next thing that we are going to do is to make sure that our strings or segment are free of defects. Okay, let me display the drill hole so that we see the way forward as a field gold values, no constraint, apply. Okay, erase temporary markers. Now if we are to go ahead and model our all, we will realize that, let me zoom to data extent. Zooming to data extent will capture the extents of my data that I used in the project, so it will capture from here to here. Okay, you realize that if I should model the all with respect to these segments, the ends of my all will end here and another will end here. So this and this are going to be the ends of my model. And as part of geological interpretation or modeling, you need to use your geological intuition or your geological knowledge or sense, because we will want to model in such a way that we infer that the all extend to this portion. So we would want to extend our model to go beyond the just at the end of the drill hole. So we want to extend the all to go beyond this segment or drill hole, and again we would want to infer the extension of the all to go beyond this drill hole. Okay, so what we need to do is to create additional segment. That one wouldn't be from any drill hole, but we would want to create it. So straight away we will do that. We will go to Soleus, triangulate, extrude and triangulate a segment. What this function means is that we would select a particular segment and we would create another segment of its kind so that we can triangulate them. That is the meaning of extrude and triangulate a segment. So I'll click that, and in the status area it says select a segment to be extruded and triangulated. So this is the segment that I want to extrude and triangulate. So I'll click on that, and I have a form here, object ID, the color of the triangulation or trisolation that you would want to give. You can select any one of your choice, but the value should be from 1 to 9. Let's say I want to give it an object ID of 1, which will have a color of brown. Then I will want to triangulate start segment and again the end segment, because the function is extrude and triangulate a segment. So whatever additional segment that we are going to create, we would want to triangulate between that segment and this original segment. So all these boxes should be checked for start segment and end segment. Now the direction to copy segment, we have forward, and backward. Forward means the segment that comes before the original one, and backward means the segment that comes after the original one. Remember, we do not have option in the window to create a segment backward. We only have forward and backward. Okay, so I'll bring back the function. So forward, and backward, we don't have only backward. So we want to create a segment here, and remember I said forward is a segment before the original one, so we will select this one. We want to create another segment here. Then we will select perpendicular to segment plane. The perpendicular to segment plane will create a segment which will have a slope angle of 90 degrees. That is the vertical and horizontal inclination of the newly created segment with respect to the original segment. Okay, and the distance is the separation of the newly created segment from the original one. So let's say 70, and the perpendicular distance, the perpendicular to segment plane, is how we are going to copy the segment by. So we are creating a segment of this type by using these parameters. Okay, so I'll click apply, and now you can see that we have a triangulation here. Another segment has been created with respect to the original one, and it has triangulated the two. Okay, in case I want to change the object ID, I can go back to the function, I can undo and break back the function. To break back the function, you can right click anywhere in graphics and select recent commands. This will list a couple of commands that you have used previously in your project. So I'll select extrude and triangulate a segment, and it says again select the segment to be extruded and triangulated. So I'll select that. Then with the same parameters, now we want to enter an object ID of 1 because initially it was 8. 8 gives red color, and I'll enter 1 which will be brown color with the same parameters. Beautiful, there you have it. So the object ID simply gives the color of the object, and I like to model my OR using the red color which is object A. So I'll go back and do that. Object 8, you can right click to select previous values 8 with the same parameters, apply. Okay, and my segment will be created. Now we do not need the triangulation or the trisolation, so what we only need is the additional segment. So I'll go to Soleus, edit trisolation, delete. Now click on it and the trisolation will be gone. Okay, the next thing to do is to extend our OR here. So we are going to create an additional segment here, and this will be backward of this segment. But remember, on the form we do not have backward, we have forward and backward. So we will create additional segment here which is forward and backward. So we will choose the forward and backward function. Then afterwards we will delete the segment here and keep the one here. So we go recent commands, extrude and triangulate a segment, and again I'm to select the segment to be extruded and triangulated, this one, and I'll select forward and backward, all other parameters being the same. Click apply, and we have it. We have created additional segment in addition to the original one from the drill hole. So we don't need this segment and the trisolation, we need only this segment. So I'll delete the trisolation, then afterwards I'll delete the segment. So Soleus, edit trisolation, delete, and it's gone. Escape. Now I'll delete this segment. Go to edit, segment, delete. Then it says select the segment to be deleted. Click on that and it will be gone. Escape to exit the function, and I'll click on this icon to do away with the blue marker. Perfect. Now we have additional segments. Remember, if we had not created these segments, we only had few these segments that were digitized from the drill holes. So let me display strings and the segment number, so we see the number of segments that we have in graphics. So I will go to display strings with string and segment numbers. I'll click on that, and the layer name is allmodel.string. Exactly, that is what we have in graphics. And the description field is D1. Position of text in the segment, the segment and string numbers. Where would we want to position it? We don't want to position it on all points of the segments, neither do we want to do that with the first point. I want to display my string and segment numbers at the centroid of each segment. You can try for this when you are working on your project to see the results, but I would want mine at the centroid. Apply, and as you can see, we have our string and segment numbers here. Let me zoom in so we see. As you can see here, we have 1.1, 1.2, 1.3, 1.4, and so on and so forth, all the way to 1.40. Remember, before we created the segment 13 of string 1 and segment 14 of string 1, we only had 12 segments. which were the segments from the drill holes. So we created additional 2. That is why we have segment 13 and segment 14. This was the one we created first, and this was the one we created last. Okay, so now let me exit. Let me do away with my drill holes, and we are left with the segments only. The next thing that we are going to do is to clean our string. Cleaning our string will eliminate certain defects associated with our digitizing of the segments. You know, whilst you digitize your segments, you wouldn't know whether you digitize with several points, so many points that were close to each other. This may have an effect when we are validating our object. So as part of geologic modeling, you would have to clean the strings of certain defects. So we will do that quickly. Remember, in the layers pane, because we created additional segments 13 and 14, we have created we have edited the original segment. That is why you can see in the layers pane the file name all.model.string now appearing in a red font, and it has a small asterisk here, meaning that you have not saved it, because if you open an object in graphics, the name of the file appears in the layers pane, and whatever work you perform in the graphics, because you have a mark here, it means that layer is the active layer. Whatever action or operation you perform in graphics will affect that particular layer, and this file is no different. That is why the name has changed, the color has changed, and we have an asterisk here indicating that we have edited the file and we need to save it. So again, I will type SF, which is save file, and press enter on the keyboard, and I will overwrite the file. So as you can see, you are about to overwrite the file all.model.string. Yes, now the name has changed to black and there is no asterisk. Beautiful. So we have saved the file. So our next task is to clean the string or the segment of defects as a result of digitizing and other factors. So we go to edit, string, clean, and we are presented with the clean string window. Now the first thing that we are going to do is to clean the file or the string out of crossovers. When I say crossovers, it's the point at which another segment crosses itself, or two different segments crossing each other. So the action that we want to do is to mark it. If you have crossovers, we want Surpac to mark it with a marker, and the target obviously is a string because we have string in graphics, and the crossover type is all crossover types, not break lines. So I'll click apply, and it says in the status area, select the string to clean. I'll click any segment and it will go for all the strings. So as you can see, all these blue markers represent the crossovers, and it has been taken care of. So as you can see in the status, in the message window, we have crossover test completed. So I'll clear the window, do away with these markers. Then we'll go to the next string, clean. Then we go to the next function. The next function is going to be duplicate point. Duplicate point is a point which lies with a specific or a specified trap distance of another point. Remember, Surpac does not triangulate points which are 0.05 meters apart, because it sees those points as very close and cannot create triangles between them. Okay, so these are duplicate points, and the action that we want to do is to remove it. If we don't remove it, it will have an effect, a diverse effect on the model that we are going to create. So we will want to remove it. Then the minimum trap distance, the lower number, and the maximum trap distance is the highest number. At what distance would you want Surpac to clean your string of duplicate points? Because Surpac does not triangulate points which are 0.05 meters apart, it is required that you specify a distance or a minimum trap distance value which is greater than 0.05, so that Surpac will clean the string all those points. It will do away with all those points to enable you create a beautiful model. So 0.2 is quite bigger than 0.05, so I chose 0.2, and the measure distance and angles, I would want to do everything in the 3D space. I'll click apply, and it says select the string to clean. Any segment in graphics will be good to go. As you can see in the message window, it says 100% complete. Perfect. The next function is going to be, I'll bring back the function. The next function is going to be spice. Okay, spice is spice refers to sharp rise followed by sharp decline and vice versa. Something like a graph which has pointed peak. That is what is referred to as spice. We would want to clean our strings of all those things. So we want to select remove. With all default parameters constant, 3D space, I'll click apply, and I'll select the string to clean. And it's shown in the message window that the spike test is finished. Okay. Now after this, I can confidently say that my segments or strings are ready to host triangulation or trisolation so that we can create our model. Beautiful. Now what we are going to do is to, first of all, let me save my file, exit graphics, and bring back the file. So now we are going to model the all. We are now at the fun part, so get ready. We are going to focus on the Soleus menu in this case. So we go to Soleus, triangulate between segments. What this function means is that we want Surpac to join one segment to another segment by means of triangles. So triangulate between segments. I'll click on that, and as you can see, the function is a triangulate automatic function. The layer name is allModel.string, as you can see in the layers pane, allModel.str. Here you can enter any object number that you want and the trisolation number. Remember, trisolation constitutes object. It's like a string giving rise to a DTM. So an object consists of trisolation. So you can have one object with several trisolations. In this case, I would want my object to have a number 8 because I want the color to be red and the trisolation to be 1. So I will click apply. And it says in the status area, select a point on the first segment to be triangulated. So I'll click on this, and again it says select a point on the next segment to be triangulated, which is this one. Okay, if you want to rotate your file in graphics, you press escape to exit the function at the status area, so you can rotate. Then you can highlight it, press enter, and bring back the function, apply. Then with the same method, we are joining this segment to this one, this to this one, and so on. So we'll select this, select that, this, that. Good. Now here we have two segments here, and this is a very controversial area, because very controversial but not all that controversial, because we would have to apply our knowledge of geology here. As you can see, this is the trend of mineralization as it moves here. And here you can see that we have two segments here instead of having one. This means that we can infer by using our little geology knowledge that there is a split of mineralization here. That is a bifurcation of mineralization. When I say bifurcation, a division or a split of mineralization. So we are not going to go by the normal triangulation method. We are going to use a different function which will help us to join this one segment to do these two segments. So we will do that quickly. Go to Soleus, triangulate, and select one segment to two segments, because we are going to join this single segment to these two segments. So I will click on one segment to two segments. And as you can see, the function states that bifurcation union as explained, because bifurcation refers to a split or division of mineralization. Layer name is allModel.string, as you can see in the graphics. And the object and trisolation number, we would want them to take the same form as this trisolation. So apply. And it says, do you wish to split the parent segment? No, we don't want to do that, so we will not check this box. If we split the parent segment, what it means is that we are going to select a point on some points on the parent segment that we would want to, the portion of the parent segment that we would want to join to any of these children segments. So we don't want to split it, so we'll leave the box unchecked. String number to store bifurcation points 32,000. What this parameter means is that before we join this segment to these two segments, Surpac will give us an additional string. It will create it automatically to enable us, and it's going to serve as the link between this segment and these two segments. That is why it is saying string number to store bifurcation points. After creating the model or triangulating or trisolation or creating the object, we will bring back the strings, and you will realize that there has been an additional string that has been created in addition to this white string, which is string 1, and that string is string 32,000. So I'll click apply and we will see the way forward. And it says select the parent segment. Because this is the single segment, we will choose this one as the parent segment. So I'll click on that and another window appears. First child segment or point. Is the first child a segment or a point? S here refers to segment, P here refers to points. And as you already know, this file that we have in graphics is segment constituting string. So it's a segment, and the first child obviously is a segment. So I'll click apply. And it says in the status area, select the first child. I can select any of these two segments as my first child. It doesn't matter. So I'll click on this one. And it says second child, segment or point. Is the second child a segment or a point? Of course, obviously, this one too is a segment. So I'll click apply. And it says select the second child. I'll click on that. And here we have it. It has triangulated or joined this segment to these two segments. Beautiful. The next way ahead is to join these two segments to this single segment. In this case, this is going to be the parent segment, and these two segments are still going to be the children segment. So I will bring back the bifurcation union function. The same parameters apply. No splitting of the parent segment. Again, we want the string to which will store the bifurcation points, a string that is going to be created between this segment and these two segments in order for us to link this to the two. So I'll click apply. Select the parent segment. This is our parent segment. First child, a segment or a point? Sure, it's a segment. I'll click this one. Second child, also a segment. Select the second child. I'll click this one and it will join it. This is beautiful. So we move on, and the rest, apart from this complex area, the rest are going to be the normal triangulation method. So I'll go back to Soleus, triangulate between segments, and I'll select the same object and trisolation number, apply. Select the point on the first segment like we did for the previous segments. I'll go on. I'll press escape. You can press F1 on the keyboard to freeze the function so that you can rotate your object in graphics. So I'll press escape. Okay, and I'll bring back the function again with the same parameters. This, join to this, and join to this. Excellent. Now that we are done with this, the next thing that we are going to do is to validate our object. Remember, when we created the segment or the string, we cleaned the string to be free of defects so that our model will be free of other abnormal defects and all that. So the next thing that we are going to do is to clean or to validate this object. Validation is just making your object accepted as a solid. So we would have to go by some checks in order to validate our object. By correcting these checks, we would want the validation process to be true, and that will reveal that our object is free of defects and errors. So I will click erase markers to do away with the blue markers in graphics. Then I will hide my strings, display, hide strings as lines. Yes, the all model.string is what I want to hide. Apply. Okay, remember in the graphics area, the layer name has been edited. We have edited the string because we have created a DTM with respect to it. So the file name again in graphics has changed to red with the asterisk. We need to obviously save it. So I'll click on save icon and it will overwrite it. Okay, good. Remember the DTM has also been created and it is now in the work directory. So we have all model.dtm. Remember, DTM files are created from string files. Perfect. So we go by our validation and we go to solid tools, validation, validate object or triangulation. I said initially that triangulations constitute an object. So any validation that we are going to perform on the object in graphics will affect the triangulations. So that's why we have validate object or triangulation. I'll click on that and we'll see the way forward. And the validation object and triangulations window will appear. Here we have layer name all model.str. Of course, that is what we have in graphics here. Or I can cancel this, exit graphics and bring back by my all model.dtm so that we have the DTM in the layers pane. Okay, so I'll go to Soleus, validation, validate object or triangulation. I'll click on that and the layer name is now appearing as all model.dtm. Report file name. As part of the validation of the object and triangulations, you will save it in the file so that you have all the errors. A report file produces the results that you would get as a result of the checks or the procedure or function or operation you are running on the file. So I would want to name this file all analysis, all underscore analysis. Okay, then the object range. Because we have only one object in graphics, we would leave the field blank so that Surpac will validate only the object in graphics. If we had several objects, say object 1, which would have been a brown color, we will specify 1,8, telling Surpac to validate object 1 and object 8. But fortunately for us, we only have one object in graphics, so we wouldn't bother filling that field. The same goes for the triangulation range because we have only one triangulation. Then we will want to set the object to a solid. Yes, that is what we want to do because we are creating a solid geological model. And these are the colors that are going to be displayed as part of the problems. So as you can see, we have the problem here and the color that will be displayed. If there is any problem associated with this model, the color will be displayed: holes, intersecting triangles, invalid edges, open edges, and reverse triangles. Let me explain this one after the other. The holes refers to the holes in the triangulation, and the intersecting triangles refers to triangles that intersect other triangles in the same triangulation. In triangulation, one triangle is joined to another triangle. There is therefore the need to check for this error. Invalid edges refers to triangle edges that have more than 2 attached triangles. The edges of a triangle should have only one. So if it has more than 2 attached triangles, then there will also be an error. Then open edges. If you have your model with an open edge, then the color will be presented by magenta. Then we have reverse triangles. Your triangle shouldn't be a reversed one. It should always be derived or attached to a different triangle in the triangulation. So all these errors, if our OR is not good, we are going to see the colors displayed for all these problems. So I'll click apply. And this is the report file that we created. Remember, we gave it the name all analysis, and the file extension is .NOT because it's a note file, and these are the factors or the problems in it. Again, when we go to the message window, we have something here: processing all.dtm, validating object A triangulation 1. I hope you remember these. there is an error. Triangulation contains open sides. These must be closed to validate the triangulation. Triangulation is therefore invalid. We would have to correct validation problems and try again. So we have not closed the edges of our model. That is why it has been marked yellow. We will need to correct the problem as stated in the message window so that our object may be validated. So we will do that quickly. We'll close the edges. As you can see, it's hollow here. I'll go to Soleus Triangulate, and this time around I'll select inside a segment. What this means is that it will take one segment and triangulate it. Okay, so I'll select inside the segment. The same object number and triangulation number. I'll click apply, and it says select the segment which is to be triangulated. I'll click the segment, and there you have it. It has closed it. I'll press escape and go to the other edge. I'll bring back the function triangulate inside segment, and I'll select the segment again, and it will close it. Beautiful. Now let's see if we can validate it. If we validate it and we have problems, the problems will be displayed again for us to verify. If not, then our object will have to be validated correctly. So I'll go back to Soleus, validation, validate object or triangulation. I'll click that, and again I would want the report file name to have the same name, so I will go and select allanalysis.net. This will take me to my work directory, remember, so I'll select that so that whatever results will be overwritten. The same parameters. I'll click apply. I want to overwrite the file allanalysis.net here. Okay, again the report file is opened. You can detect that from your work directory. It's over here, allanalysis.net. So let's see what we have in the message window. Validating object A triangulation 1. Triangulation is closed. Remember, we just closed it, so we have corrected the error. Triangulation successfully validated. So we are good to go. We now have a very nice model. We have corrected the error which stated that we have closed edge, we have open edges, and the problem, and that was the problem, so we needed to close it. We did that and we validated it, and we now have our triangulation successfully validated, which means is that we now have an all model free of errors. Remember, again, the file has changed to red, the file name with an asterisk. We will need to save it because we have validated it. I'll click save all model and to overwrite it. Warning, you are about to overwrite the following files: all model.dtm and all model.string. Yes, because DTM files are created from string files, so if you are saving or overwriting a DTM file, obviously it will overwrite the string file, so I'll click yes. Beautiful, and the file name will change to black again. Okay, so we have created our geological model. Let me display the drill holes and see how it looks like. From the assay, good values, no constraints, apply. Perfect. So this is the geological domain or ore of the area. As you can see, most of the mineralized zones are falling inside the ore. Let me bring this tool icon here, scale and transparency, so we can view it better. Can drag to increase the transparency of your model. Can drag back to close it. Okay, so there you have it. This is the geological model of the area. Thank you for watching, and catch you later in the subsequent lesson. Bye for now.